Okay, today we're continuing on with Module 5, Lesson 18, and your learning goal today is I can draw rectangles and rhombuses. We already know what rectangles are and we already know what rhombuses are, but today we're going to look at them a little bit more in depth, and we're going to draw them using what we know about their attributes and properties. So, reviewing what we learned yesterday, hopefully in your trapezoid you drew it so that there was at least one pair of parallel lines. In my drawing here, I made it so that the red lines here are parallel. Parallelograms are different than trapezoids because instead of just having one set of parallel lines, they need to have how many? Two pairs of parallel lines. So in my parallelogram, I drew the the red and the yellow lines to be parallel. Okay, so that answers our first question. What's the difference between a parallelogram and a trapezoid? Now, go ahead and draw a rhombus in your notebook. Write the word rhombus and look at the spelling of the word rhombus. It's spelled differently, right? So make sure you take a look at it. Now, as we talked about earlier, a rhombus is just a parallelogram, which means it has how many pairs of parallel lines? Two. So it's just a parallelogram, but what's the difference? All the sides, all four sides need to be congruent. Now, I'm not using a ruler, you are, but how can the person looking at your book doesn't know for sure if they're congruent. So how could you show that all four sides are congruent? You can use tick marks. So when you draw a rhombus, make sure you draw tick marks to show that all four sides are congruent. So, what's the difference between a rhombus and a parallelogram? Well, a rhombus is just a special type of parallelogram where all four sides are congruent. Answer yes or no, okay? Are all trapezoids also called parallelograms? No. Are all parallelograms also considered trapezoids?
Yes.
Are all parallelograms also considered rhombuses?
No.
Are all rhombuses also considered parallelograms?
Yes.
Are all rhombuses also considered trapezoids?
Yes.
Very good. Let's make ourselves a little Venn diagram like this to help us keep track of it. So, in your notebook, draw a big circle, okay, called quadrilaterals. Now, we know that there is a special type of quadrilateral called a trapezoid. And I'm going to write the word trapezoids inside quadrilaterals because if I have a trapezoid in here, is it also inside the quadrilateral circle? Because all trapezoids are also quadrilaterals. But could I draw a quadrilateral like that? Is that one a trapezoid? No, it doesn't have at least one set of parallel sides. So does it belong inside the quadrilateral circle? Yes. Does it belong inside the trapezoid circle? No. So that's how we're going to sort things, okay? So go ahead and draw yourself a trapezoid and draw yourself a quadrilateral and put it into the right place in your circle. How can we further categorize trapezoids? There are certain kinds of trapezoids called what? Parallelograms. Good. So inside that circle, draw yourself a parallelogram. Is your parallelogram also inside the trapezoid circle? Is it? Yeah. Because is this parallelogram also a trapezoid? Yeah. Is it also inside the quadrilateral circle? Yeah. Because is it also a quadrilateral? Yeah. Interesting. Now there are certain types of parallelograms, if I zoom in. Okay, now that I've zoomed in, there are special types of parallelograms called what? We just learned about it today. Rhombus. Good. And go ahead and draw yourself a rhombus. And the only way you can tell that it's a rhombus is if all four sides are congruent. So draw it like that. You'll notice your rhombus circle is also inside your parallelogram circle because that rhombus is also a parallelogram. But are there some kinds of parallelograms that are not inside your rhombus circle? Yes. So are all parallelograms also rhombuses? No, but are all rhombuses also parallelograms? Are there some trapezoids that are not parallelograms, that are not inside your parallelogram circle? So that's why this one's outside. But are all parallelograms also inside your trapezoid circle? Are they? Yes, because all parallelograms are also trapezoids. And then are all trapezoids also quadrilaterals? But are all quadrilaterals, like this one out here, also trapezoids? No. As we know, a rectangle has four right angles. So go ahead and don't assume that the person looking at your math notebook or your math drawings knows it. Use these special markings right here to show that it is a right angle. If you do not draw these, I cannot be convinced that it is a right angle. No matter how much my eye looks at it and thinks it probably is a right angle, if you don't have these markings, I cannot be absolutely sure. What else do we know about rectangles? Well, we know that opposite sides are what? Parallel. Okay. We also know that opposite sides are congruent. So we can use tick marks to show that those two are congruent, and I can use different tick marks to show that those two are congruent. Very good. Now, same thing. In your notebook, draw a square. We know that squares are just special types of rectangles. Again, we can draw that they have 4 right angles. And this time, how many of the sides are congruent? All 4 of them. So we can draw the same tick mark on all 4 to show that they are congruent. This Venn diagram over here shows you that all squares are also inside the rectangle circle. Do you see that? So all squares are also rectangles. But there are some rectangles that are inside the category of rectangles, but does it belong inside the square circle? No. So let me ask you, are all rectangles also called squares? No. Here's a rectangle that's only called a rectangle. It's not called a square. Are all squares also called rectangles? Yes. When we connected diagonal vertices, we noticed 2 things. The first thing we noticed is that the 2 diagonal lines bisect each other. Remind me right now, what does bisect mean? It means it cuts the lines exactly in half. That means that this distance here, the blue distance, is congruent to this blue distance. And the green distance here is congruent to this green distance here. I also can see that right angles are formed by the 2 diagonal lines. Connected diagonal vertices, again, we can notice that what kinds of angles are formed? Right angles. Do you see that? So you need to know for rectangles and squares and rhombuses, when you connect opposite vertices, it'll make 90-degree angles. Do you see that? Also, how far is it from here and here? Does it bisect each other again? Go ahead and measure. And then tell me, is it the same or different as the other lines that are the other diagonal line? With a square, by the way, this is a rectangle with all sides equal. Is that also called a square? With a square, all 4 of these lengths will be the same because they bisect each other, so we know these 2 will be the same. But actually, it turns out that all 4 are the same. Yesterday when we were talking about this, we saw that the pairs all touched one set of parallel lines, right? Now, do you see how these ones are the same again? And these ones are the same again? Do you see that? Why is that? I want you to turn to your partner and tell them why these 2 are both 70 and why these 2 are both 110. If you can see that these 2 add up to 180 and these 2 add up to 180. Go.